Hello, in today's video, we are going to be taking a look at our second heat calculation. So in our previous video, we did heat of fusion, Q equals mHF. Today we are doing heat of vaporization, Q equals mHV. So we are going to need our calculators and our reference tables again. So heat of vaporization is the heat needed to vaporize or boil or evaporate a sample. The HV constant is equal to the amount of heat needed to boil, evaporate, vaporize 1 gram of a substance at its boiling point at a constant temperature. So heat of vaporization is going to be an indicator of the strength of the intermolecular forces. The higher the heat of vaporization, the stronger the intermolecular forces, because the more heat is needed to separate out the molecule. All right, so our formula is listed on the back of the reference table. Next to the formula, it would be very wise to write boil/condense. So we will use this for liquid to gas or gas to liquid. So boiling is going to be an endothermic process. Condensing would be an exothermic and would be releasing the energy. Q is always heat, and that's measured in joules. M is mass, that's measured in grams. And HV is the heat of vaporization, the heat needed to boil 1 gram of the substance at its boiling point. For water, heat of vaporization is 2,260 joules per gram. So what that means is it takes 2,260 joules to boil 1 gram of water at its boiling point. All right, so in our first example, we are calculating how much heat, so that is Q, so Q is going to be our unknown, must be supplied to evaporate. So evaporate is liquid to gas, so that would be, heat of vaporization. We have 50 grams, so we can plug in 50 grams. And since we are using water, we can use the standard value for water, 2,260 joules per gram. And again, you can look that up on table B on the front of your reference tables. So in our calculators, we just do 50 times 2,260, and that gives us 113,000 joules. We want two significant figures, so 110,000 joules. You could also put your answer in scientific notation if you would want to. All right, question number 2. We are starting with 12,750 joules of heat, so that's going to be the Q value, are used to boil. So that tells us which formula we can use. So we're doing MHV. And we are using water, so we know we can use the constants off of table B. Calculate the mass of the sample. That's what we're looking for. So my Q is the heat. That's 12,750 joules. Mass is what I'm looking for. And since I am using water, I can use 2,260 because that is the heat of vaporization for water. In order to solve this, I just do 12,750 divided by 2,260, and that gives me 5.64 grams. And let's see, I actually need 4 significant figures, so I should have included a 2 after that because I had 5.6415, so 5.64 grams, or 42, sorry, grams. All right, question number 3. We have a 45-gram sample of an unknown liquid. So this is not water, therefore we cannot use the values for water given on table B. My Q is 85,000 joules, and this is evaporating, so therefore I know I'm using heat of vaporization. Also, they're telling me I need to find heat of vaporization, so that would be a huge clue at which formula to use. So we have 85,000 joules. 45 grams, and H of V is what I am solving for. So all I do is 85,000 joules in the calculator divided by 45, and that gives me 1,889, but I only want two significant figures, so 1,900 joules per gram for the heat of vaporization of this unknown liquid. Now, question number 4. We need to compare the strength of this unknown liquid to water and their intermolecular forces. So, water has a heat of vaporization of 2,260 joules per gram. So, water must have stronger IMFs because it has a higher heat of vaporization. So the larger the heat of vaporization, the more energy it requires to vaporize that sample. So therefore, the more strongly attracted the particles are to each other. Now, again, as a review, we can use this formula for boiling or condensing. So, boiling is endothermic. So, if we're working with water, we're absorbing the 2,260 joules per gram. Condensation is the reverse process. So, therefore, it is exothermic. So, we would be releasing energy. And again, if it's water, or water vapor, we would be releasing 2,260 joules per gram.